Welcome learners for the lecture 5 of a differential geometry. Today we are discussing about the same as another topic for representation of a surface. Okay, let us go started as a representation of a surface. In our study of the surface, we shall consider only a ordinary point. In the previous lecture, we discussing about the ordinary points as well as singularity. If we generated as a r1 into, if suppose that r into r is r1 into r2 is not equals to 0, it's called as a ordinary point. If we given as a 0, it's called as a singular point. Okay, they show as a singularity. If we rank will be generated as a 1 or 0, this is called as a singular point. If rank will be greater than 1 and 0, this is called as a ordinary point will be showing. Okay, let us go start a representation of a surface. We shall consider only ordinary point on the surface. This means that the domain of the parametric domain means we given as a definition. Second definition will be show as the domain of the parameter u and v will be restricted to the every point. Okay, uv on the surface of the ordinary point. We shall study the properties of a surface in the very useful for the parametric transformation is generated to the locally 1-to-1. Since such a study depend upon the portions of a surface, we consider the entire surface as a collections of the part, each part being a given a particular parametrism, and the adjacent part are related by the proper parameter is considered as a transformation will be generated. Okay, this is the representation of the surface. Then first definition, representation of the surface will be generated. A representation r of a surface is, r is representation will be generated. Surface s is considered as a surface notation s of a class R in a E3 is a collections of points in a E3 covered by a system of the overlapping part, that is the Sj, where each part of the Sj means surface of a J position is given to the parametric equation of the class R. Each point is given as a common portion in the two parts that will be generated Si and Sj. Means direction will be generated x-axis, y-axis and z-axis for the change of the parameter for the one part aside to its adjacent part. Means the one part will be given as to the form. If we generated x, y, z axis, will be considering first direction, opposite direction as well as to the adjacent part will be considering in the form. Is the proper parameter of the transformation R. Let R and R dash be the two representation of a class R. For second definition will be considering surface will be generated at. Let Sj and Sj dash be the two different system of overlapping to the part of the covering S corresponding to R and R dash. They represent to the equivalent part of the composite family of the part. Sj and Sj dash satisfy to the condition of the common portion of this part. Same overlapping condition will be generated and parameter will be generated of the point Sj to the parameter of the same point will be considering as a proper parameter of the transformation in the class R. This will be generating to the overlapping form as a Sj to Sj dash at the point P by the proper parametric transformation of a class R will be considering to the form. Then theorem will be depending in the form. The notion of the motions of a R equivalents of a representation of a surface is a equivalent relation. Okay, proof. Let R be the representation of a S and let S be the composed of overlapping part Sj. What we say in the proof of this form, let R be the representation of a S and let S be the composed overlapping part Sj. Since the change of parameter from a Sj to Sj dash given to the proper parametric transformation of a class R. To show the relation, that is the R equivalence of a representation, R is a reflective. Okay, equivalent representation will be show R is a reflective. Let the relation R be the equivalent to R dash, then Sj to considering the Sj dash be the two overlapping part in the two representation which will be shown to the P points of a overlapping portion. If suppose that R and R dash are equivalent, there exists a proper parametric transformation phi at the P from the Sj to Sj dash. Okay, P will be considering for the overlapping of a surface generated as the Sj to Sj dash. Since the proper parametric transformation is locally 1-to-1 or possessed to the inverse transformation, phi minus 1 consider means the inverse form will be generated to the form. This is the inverse transformation definition is considering as a lecture third. Okay, they considering. If we does not consider as a any concept will be does not clearing, then we get it as the this part will be generated exist at the point P overlapping to the Sj and Sj dash. In other words, there exists a proper parametric transformation phi inverse from the J to J dash. Thus, R dash is a equivalence to R, so that the relation of a R is equivalence to the R is a symmetric form will be generated. Okay, this will be considering as a theorem from the equivalence notation. Then, if we considering as a three position for the value will be generated, three position part will be generated, that is a let R, R dash and R double dash be the representation of the class R to the surface S. So means the value will be generated R similar to R dash as well as the R similar to R double dash. Hence we considering as a, all these value R and R dash are equivalent. There exists a proper parametric transformation phi at the common point P1 in the overlap of the family is J is J dash hence to considering to the value of a changing to the parameter for the overlapping value J dash to the J double dash is J dash to the Sj double dash given to the proper parametric transformation of the value that will be generated to the form. Okay, they will be generated as a psi to Sj dash to Sj double dash since phi means if we given as a one representation of the surface, two representation of a surface as well as three representation of a surface, overlapping value of the class R2 changes to the form Sj, Sj dash and Sj double dash to the equivalent value will be generated. Hence we given to the value of the representation to the surface is a transitive. Since the notation relation will be complete to the R is a reflective, hence class R is a reflective, we get it to the more value will be generated, hence considering as a notions of the relations of a equivalent of a class R is a reflective also, symmetric also and transitive also is equivalent relation which completes to the proof of this theorem. Okay, means that this equivalent relation introduced to the partition into the family of a surface R, splitting them into mutually disjoint equivalent classes. Each classes will be considered to the form as a value. This equivalence relation introduced the partition of the two family of a surface R will be splitting into mutually form of the surface equivalent to the another. This leads to the definition of this form. Definition third will be considering a surface S of a class R in E3 is a R equivalence of a class representation. Hence, a surface consists of a different overlapping portion related to the one another, that is a proper parametric transformation, and all other surface related to the given by the equivalent relations of a class R. We make to the study of this property and show to the how to the there is a reflective as well as symmetry form will be generated to the equations.